Hey everyone, and today we talk about MSE and MAE. When we talk about regression tasks, these two metrics are roughly dominate, and MSE is our squared deviation, and MAE is absolute deviation. So both metrics share the same idea. We compare our predictions with the true answer overall for all of our objects, and both of them use symmetric functional form so that under predicted by one is penalized the same over as predicted by one. Um, this is how it looks. Both of these functions on the same axis, MSE and MAE. It's not actual representation of these functions because basically we see just x squared function and absolute x functions, not this kind of form. But just for simplicity of visualization, we use such graph on the right side. But basically, what is important to see is that all these two functions, how they are written, and this is just an idea of how this function might look, but it actually looks a bit more difficult to visualize it properly. And and again, this is our formula. MSE, how it is formed. We have our loss function here within parentheses. This is squared one, so this is square deviation, and we have a sum symbol here, which means we will sum all of our objects, all of our loss functions together into one number, and we have to divide that number by amount of objects that we had. MAE is mostly same, but instead of squaring our loss function right here, we take absolute value, and that's it. Another name, another way how we call a single object is a margin or residual. It's also very common in terms that are used in machine learning, so be familiar with them. All right, the way how we visualize MSE and MAE on a single object, we can just imagine one object and plot MSE, MAE, and MSE, as I already showed you before, looks like smiling parabola, convex bowl shape, grows faster and faster as we move away from zero. And MAE looks like V shape, check mark, and it grows constantly with the same rate. Its delta doesn't change from time, from a particular period to particular. Uh, so it doesn't matter how far we went, how big is our error for MAE, the penalty is always uh, penalize us the same way, proportional to the air distance. So MAE doesn't amplify its punishment larger for bigger mistakes. So it's the basic difference between MSE and MAE. We can look at this graph again and see that how our error changes if our prediction is more far from actual answer. So if our prediction goes farther and farther from the truth, MAE punish us the same way all the time. MSE punish us harder and harder. We can see that exactly this moment, uh, where both of them punish us the same way, and then MSE starts punishing us harder for mistakes. All right, let's continue further. And suppose, let's look at one example. Suppose we have two objects with true target values 5 and 10, two models producing the following predictions. Um, it produced prediction 5 for the first object and 20, 12, sorry, for the second object. And we have model B. Yeah, it also produces two results, 6 for the first object and 11 for the second object. And we have MSE formula again. And we can calculate error on each object to see margin, residual, or loss function for one object. And have here our prediction, our target, we got 0 error, good result. And for the second object, our first model got 2 as an error, and we calculate MAE for the first model, 0 and 2, and we got 1 as our error, as our quality functional. For the second model, we got 1 and 1 for both objects, and we can see it here, just 1 and 1 as our error, and we also divided by the amount of our objects in the data set, and we got 1, and we can see that MAE punishes us the same way. Doesn't matter if suppose we did a bigger mistake in some examples like this one, and we did great job for another one. Still, we get the same result as if we made the same mistakes for all of our objects. So for MAE, doesn't matter if we sometimes we do bigger mistakes, sometimes we do smaller mistakes. It both models give the same MAE one, and predictions differ significantly, and that's one of the reasons why MAE alone might not be enough to choose better model, because from here we cannot see the difference between these two results, and that might confuse us in some cases. In case of MSE, we will get a bit different result for the same task. We can see it right here. Our predictions, all stuff is the same. We have MAE on the left side that we already seen, and we have new MSE calculations on the right side. And we can see that in this case, when we did zero mistake for the first object, but we did bigger mistake for the second one, when we calculate our MCE, comparable to the case where we did the same smaller mistake, the first model gets higher mean squared error metric because MSC penalizes us larger for bigger errors. And right now we can see the difference between these two, and we can more clearly define for ourselves which model is the best, which model we would like to take for and work with. That one that gives us smaller MSE. In this case, model B. Model B, yeah, does gave us better result. And again, key takeaway about function term, loss function, quality functional, and metric terms. Basically, again, loss function is the measure of an error for a single specific object, and the quality functional is MSE and MAE that we already discussed right now, just now. And metric, final measurement closely tied to the business task, and I think we'll talk about it a bit later. And there are much more metrics that might be presentable for business to be interpreted for non-technical stakeholders. Because MSE, MAE, it's not really clear about what it is for business people. And definitely you won't spend time of explaining how MSE, MAE works and all this stuff to business owners. You want to have particular simple metric that can be measured for business. So key summaries. Loss functions measure the error of a single object, transform into a numerical value. Quality functional is how MSE MAE computes the average error across the entire dataset. Metric is the final measurement aligned with business meaning. So, as important takeaway is that MSE MAE might be different, gives us different understanding of how our models works for those cases where we have bigger error, bigger deviation for some objects and smaller deviation for other objects. If we want to be sure that overall quality is better and take the best model, so MSC might be more accurate in these cases. All right, thank you and see you next time.